Very good morning, students. In previous classes, you have you have learned about total first chapter, all the topics or concepts related to real numbers, as well as second chapter, polynomials, are done till previous class. Now, you people are going to learn about the new concept, that is third chapter of your insert textbook, that is paid off linear equations in two variables. Already you people know about linear equation in two variables. That is, the standard form of linear equation in two variables is ax plus by plus c is equal to 0, where a square plus b square not equal to 0. This is the general form or standard form of linear equation in two variables. Linear equation in two variables that you learn in previous class, and its graphical representation also learned by you people in previous class. Now this chapter you will learn about pair of linear equation, pair of linear equations in two variables, So that is standard form of pair of linear equation to variables is a1x plus b1y plus c1 equals to 0. Another equation a2x plus b2y plus c2 is equal to 0. The condition is a1 square plus b1 square not equal to 0 and a2 square plus b2 square not equal to 0. This is the general form of pair of linear equation in two variables, that is a1x plus b1y plus c1 is equal to 0, where a1 square plus b1 square is not equal to 0 and a2x plus b2y plus c2 equals to 0, where a2 square plus b2 square not equal to 0. This is standard form of linear equation in two variables, only one equation when pair is given. Pair means you know well two. So this is another name of this is system of linear equation in two variable. System of linear equations, and even you can call it as pair of linear equation in two variables. System of linear equation in two variables are simultaneous form of linear equation in two variables. So we have three names for this, but in general we will use, in your standard you will use pair of linear equation in two variables or else system of linear equation in two variables. But this you will learn in higher classes. This is not required in this standard. So you will learn or you will use for in this class this form as pair of linear equation in two variables or a system of linear equations in two variables. So there is a chance to ask one more question, that is write a general form of pair of linear equations in two variables or else system of linear equation in two variables. For both same, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0. Condition a1 square plus b1 square is not equal to 0 and a2 square plus b2 square not equal to 0. By using these forms, we can represent this system of linear equation two variables. One is graphically. When any word problem is given, we can write it as geometrically. By using its geometric form, we can represent graphically. Graphically means putting or plotting on graph after writing its coordinate form. Already you learn how to write in previous class. That extension of that topic is in this class. So once again I am repeating, students, topic of this chapter, name of this topic is pair of linear equation in two variables, and the standard form of linear equation two variables as you learn in previous class, that is ax plus by plus c is equal to 0, where a square plus b square not equal to 0. And the second standard form of pair of linear equation two variables or else system of linear equation two variables is a1x plus b1y plus c1 is equal to 0. Another equation is a2x plus b2y plus c2 is equal to 0, where condition is must. Without this condition it is not applicable. a1 square plus b1 square is not equal to 0 and a2 square plus b2 square not equal to 0. Now in this first exercise, this topic contains 6 exercises. I mean 6 parts, 6 exercises. In the 6 exercise, first exercise you will learn how to write a geometrical representation of given word problem. And the second exercise you will learn what are the different conditions for having one solution, having infinite solution condition, having no solution condition. One solution and infinite many solution conditions, we can say it as the equations are consistent, and when the pair of linear equation contains infinite many solutions, we can say it as dependent pair of linear equation two variables, and when there are no solution, inconsistent. And graphical representation, when the pair of linear equation contains one solution, they are intersecting lines. When they contain infinite many solutions, they are coincident to each other. When there is no solution, they are parallel to each other. As we know, when two lines doesn't intersect at any point, means no solution, they are parallel to each other. These are all the conditions you will learn in second exercise, as well as graphical representation you will learn. In third exercise you will learn about different algebraic methods. That is nothing but, first you will learn about substitution method, and after that exercise you will learn about elimination method. Fourth exercise you will learn about cross multiplication method. Fifth exercise, first exercise geometrical representation, second exercise conditions, different conditions for pair of linear equation two variables, arrays, system of linear equation two variables. Third exercise and graphical representation also, and third exercise you will learn about substitution method, one of the algebraic method to solve the pair of linear equation which are in the form of a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. And the fourth exercise you will learn about elimination method, how to solve pair of linear equation two variables. And fifth exercise you will learn about reducing into pair of linear equation two variables method. And fifth exercise you will learn about cross multiplication method. Sixth exercise you will learn about reducing into pair of linear equation in two variables. Totally we have 6 exercise, 6 parts. So now this class you will learn about how to write geometrically, and after different conditions for this pair of linear equation two variables, nothing but system of linear equation two variables. In this part or in this class you will learn. So we will continue this. First you note down these what are the key points we have. First, standard form or general form of linear equation two variables, you learn already in previous class. This is standard form of pair of linear equation two variables or system of linear equation two variables, this condition. So both of these are forms you learn it, note it down and refer the textbook, everything you have. Then we will continue how to write a geometrical representation when it is given in word form. So as you learn students, the standard form of pair of linear equations or system of linear equation two variables is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0. Now some problems are given, word problems. By using these word problems, how to write geometrically I will teach, and the rest problems whatever given home assignment you need to do as homework. First problem, Aftab tells his daughter, 7 years ago I was 7 times old as you were, then also 3 years from now I shall be 3 times as old as you will be. Isn't this interesting? Represent this situation algebraically and graphically. First we will show algebraically. Graphically next exercise we will learn. After tells his daughter 7 years ago. What's the meaning of ago? Before. I was 7 times old as you were then, at the time. And also 3 years from now, after 3 years, I shall be 3 times old as you will be. So we have to represent. Actually, we doesn't know what is present age of Aftab or his daughter. So let we consider present age of Aftab. So Aftab, let me take x years. So here we are dealing with a linear equation two variables, so we can take x and y. You can take u and v, that is not an issue. Present age of his daughter. Present age of his daughter is, let v as in y years. So here, as per problem, according to the problem, 7 years ago, we know what's the meaning of ago. Minus, after is I was 7 times old as you were. I mean, after is 7 times old to the his daughter's age. So when 7 years ago means, for example, one person is 30 years. What will be his age 7 years before? Yes, 30 minus 7, 23 years. So we should subtract. One person age is 38 years or 35 years. If we subtract 7, it will be 27. So one person age is 13 years or 14 years. What will be that person age 7 years before? Yes, 7 or 6. Similarly, here we consider as x. So x minus 7. According to the problem, x minus 7 of equals to 7 of y minus 7, because when father says decreased by 7, daughter says also will be decreased by 7. So if you simplify, students, so we get this form. So then after x, write all variables one side, constant, but write in standard form. Always we should write in standard form. So if you simplify, what we get, students? Yes. So 49 minus 7, how much? Yes, 42. So we got equation 1. Linear equation in 2 variables. But paid they gave now, paid means 2. So again we will recollect that and we will apply same method to get one more equation. That is given, I shall be 3 times as old as will be 3 years from now. So 3 years after, 3 years from now, nothing but after 3 years. To understand easily, I said after 3 years, but 3 years from now, nothing but after 3 years. So again, same condition, after we should add, and 3 times of daughter is also 1 plus 3, again plus 3. So we got 3y plus 9 and simplify it. Then after we get x minus 3y plus 3 minus 9 equal to 0. X minus 3y minus 6 is equal to 0. This is equation 2. And already we got equation 1. So we got 2 equations. That is why paid off linear equation in 2 variables. As we discussed just now, this is geometrically, algebraically. Nothing but by using variables. Again, I am repeating, students. Let me consider present age of Aftab as x years. Present age of his daughter is y years. As we are discussing pair of linear equation 2 variables. So after 7 years ago means minus we will do. So after doing minus, we got one equation simplification. You learn this method in earlier class also. We apply same thing. But also we ago means minus we will do, as you know. Again after 3 years, second condition, x plus 3 you have to do. After simplification we got one equation. So we got two, equation 1, equation 2. We have 2 equations. We have to show graphically also. So algebraically is done. Even graphically also how to represent you have learned in previous class. Same method we will apply here. There is no different method. Again, just once you study the students. Yes? Any doubt? Yes. From condition 1, 7 years ago we got one equation. Condition 2, after 3 years we got one equation. So these 2 equations we are representing graphically. So take a graph sheet. Before applying this method, first we should take the coordinate form. Yes, can I rub the board, students? Yes. So we are showing, we have shown already algebraically. Same thing we are showing by using graph. I mean by plotting on graph. So let me take first equation. What is given, student? First equation? Yes. Then after, is it wrong to write 7y minus 42? Yes. When we shift to that side, take one variable x and minus 7y can change into plus 7y minus 42 and make solution box or else represent by using numericals. This is nothing but write in coordinate form. You take x, y. By putting y value something, we will get x value. But students, remember, when it is in fraction form, if you have any denominator, take multiple of denominator, because It is not possible to represent some decimal numbers. 1.5, 2.5 like that we can show, but 1.333 we can't represent. Non-terminating, repeating we can't represent. It is difficult to plot. That is why try to take always whole numbers. I mean integers, any integers which are possible. So better to take 3 or 4 values. Depends on depends on situation. Let me take y is equal 0. If you put y is equal to 0, if you want, you do 7 into 0 minus 42. 0 minus 42 how much? This is 0, we know, minus 42. So put here. So minus 42. Again, you take x is equal to 1. If you put x is equal to 1, what happens, students? Yes, 7 minus 42, that is minus 35. So put minus 35 here. So we got. Again, take 2. If you take 2, what happens, students? 14. 7 2s are 14. 14 minus 42. How much, students? So 14 minus 42 minus 28. Yes, all are multiples only, of course. Let me take 6. 7. If you take 6, y means I want to get 1 0 also. On x-axis 1 point, on y-axis 1 point. I want to take to do easily. So we got 0. So 0 we put. Enough. So write this all the points as in coordinate form to plot and graph. So x value first, abscissa, ordinate, abscissa, ordinate, abscissa, ordinate, abscissa, ordinate. Put on graph, plot on graph. We can represent graphically now. Again, one more equation. What is given, student? Yes, x minus 3y minus 6 equal to 0. Is it wrong to write? Again, shift to right side. Yes, we got it. Again, put on that algebraic, take a solution box and write in coordinate form. Then after plot and graph, we will get two equations, whether they may be intersecting, they may be parallel, they may be coincident. This exercise you will learn only graphically, but next exercise, before the next exercise, I will say the conditions, how to check whether they are intersecting lines, coincident lines, or parallel lines. We will. First, let me complete this graphically. You know, these all the methods you learn in early class, previous class only. No issue. Directly you can do. Again, take x, y. Put x, y is equal to 0, students. Yes, same method. 3 into 0 plus 6. So this is 0, no value. So 6 we get. Again, 1 you take, students. Yes, 3 plus 6, 9. So 9 we got. If you take 1, 9. Let me take a minus 2, because I want to get one negative also, 1 0 also. So if you put a minus 2, the value is 0. Put 3 3s are 9 plus 6, 15 we got. So we have here these values. Again, write in coordinate form, students. 6 comma 0, 9 comma 1, 0 comma minus 2, 15 comma 3. As you have learned, abscissa, ordinate. So here plot by minus 42 comma 0, minus 35 comma 1, minus 28 comma 2, minus 0 comma 6 on graph. One line you will get, and this one also one line you will get. So here, if you observe, it will be, so you will get one intersecting lines, because it contains one unique solution. So the graphical representation, if you plot and graph represent, you will get at most one intersecting lines like this. So plot and graph, as you learn, take one graph sheet and plot and graph. Okay, take scale. Take scale appropriately, because we have a larger value minus 42 on x-axis. So better to take 5 units on scale. Take graph sheet and plot. Draw one vertical line, horizontal line, as you learn in earlier classes, and after that take scale conveniently to draw. On x-axis, better to take 1 centimeter. Here 1 centimeter unit you will get in a graph exactly equals to 5 units. And on y-axis, what is the highest value? Y-axis we took only 6. So you can take 1 centimeter is equal to 1 unit also. Plot and graph. If after representing graphically, you will get two intersecting lines. So this is the way to represent geometry algebraically as well as graphically, that you learn already in your previous class. Two more problems you have in your exercise NCERT textbook, and some more home assignment problems also will be given. Please solve it by using this one and refer textbook furthermore.